final problem in this chapter is directly related to a lab that we're going to do for Chem 100. We're going to find the experimental molar mass of a metal. It may not be nickel like it is in this problem, but we're going to do the same basic type of experiment. We're going to collect a gas, and it's called being collected over water. What that means is the gas is mixed together with some water vapor. And the goal is to find the molar mass of nickel. Well, we know what the molar mass is. Molar mass is grams of nickel divided by moles of nickel. And we can measure the moles of nickel in the lab. It's 0.254 grams. So we know the numerator in this problem is 0.254 grams. The work is to find the moles of nickel. And like I said, we collected this gas over water, which means when we measure the total pressure in the room, that's called the atmospheric pressure. In this case, the atmospheric pressure was 775.7 millimeters of mercury, and we measure that with a barometer. The total pressure in our experiment is equal to the pressure of the gas that we make. And the gas that we make, we have to figure out from the balanced reaction. So our reaction is nickel solid reacting with hydrochloric acid, aqueous, and this produces nickel 2 chloride, aqueous, and hydrogen gas. So going back to this total pressure, the total pressure is the pressure of hydrogen that we create from this reaction, but it's mixed with water vapor, so we also have water mixed in with that hydrogen gas. We know this number, the pressure of water. We can find this in a table, and when you get to this lab, in your lab manual, there's a table that tells you the pressure of water vapor. You just have to know what the temperature of the experiment was. So this time, in this problem, the temperature was 23 degrees, and if you look up in your lab manual, at 23 degrees, the pressure of water is 21.1 millimeters of mercury. So the total is 775.7, and the pressure of water is 21.1, so we can get this pressure of hydrogen by subtraction. That is 754.6 millimeters of mercury. Just like in the stoichiometry problems we've been working, if we know information about the gas that's created, we can figure out information about the reactant nickel that created it. And we know the pressure of the gas, we know the volume of the gas, we know the temperature, so we can use PV equals nRT to find the one variable we don't know, which is the number of moles N of this gas. So if we solve for N, it's PV divided by RT. The pressure, it's very important when it comes time for this lab that you do not use the total pressure, you do not use the pressure of water, you only use the pressure of the gas that we create. So in this example, it's hydrogen gas, 754.6 millimeters of mercury. but we have to convert that from millimeters of mercury into atmospheres. We're going to multiply that by the volume, and the volume of gas was 110 milliliters, which is equivalent to 0.110 liters of gas. We need liters to cancel the liters in the gas constant. So 0.110 liters. Gas constant and then the temperature, 23 degrees Celsius. We convert that into Kelvin. And we solve for the number of moles. We'll get 4.492 times 10 to the negative third moles of hydrogen. Now we have the denominator we need, but this is moles of nickel, so we really don't have that because this is moles of hydrogen. So we have to use stoichiometry to figure out how many moles of nickel had to react to produce 4.492 times 10 to the negative 3 moles of hydrogen. In this case, it's a nice 1-to-1 ratio. So 1 mole of hydrogen came from 1 mole of nickel. So in this example, it is 4.492 times 10 to the negative 3 moles of nickel. So now we have our 2 parts for the molar mass of nickel. The grams of nickel given in the problem, 0.254 grams. The moles, 4.492 times 10 to the negative 3. And when we divide those two, we'll get an answer of 56.55 grams per mole, which is close to the periodic table value, 58.69. So this is not something that you'll see on an exam for the lecture part. This is a complicated problem. This is a full experiment that we will do later this semester. So when it comes time for this lab, you can review this video. It's going to help you when you do the calculations.